Hi, so today we'll focus on the gear faults. So a gear is basically a machine element designed to transmit force and motions from one mechanical unit to another. Gear faults typically occur in the teeth of a gear mechanism due to fatigue, spalling or pitting. These can be manifested as cracks in the gear root or removal of metal from the tooth surface. They can be caused by wear, excessive loads, poor lubrication, backlash, and occasionally improper installation or manufacturing defects. The various types of gear defects are a gear tooth wear, tooth load, gear eccentricity and backlash, gear misalignment, cracked, chipped or broken teeth wear, or a hunting tooth problem. Now, a normal spectrum indicates no problems in gearboxes. Having said that, presence of a GMF is not always indicative of a fault. A running gear excites the gear mesh frequency, which can be calculated as GMF is equal to the number of meshing teeths into the RPM. Now, gear tooth wear spectrum ideally looks like this, wherein you have a high amplitude GMF with the presence of sidebands visibly looking like this. Tooth load or significant load imposed on gear teeth, which looks like this. In such scenario, the GMF is quite significant and it even varies with variations in load. Gear eccentricity and backlash. Though being a very rare occurrence, this is a very considerable fault considering the fatalities it brings to the equipment. In a gear backlash, you ideally have a family of sidebands around the GMF. In eccentricity, you have sidebands also present around the one into gear. The shift between the mating parts of the gears is ideally what we call as the backlash. Now the gear misalignment quite prominently visible here. It may have a 2 into GMF and also 3 into GMF is a possibility. Now cracked, chipped or a broken tear teeth. In such cases, the teeth are ideally broken, as can be very clearly seen in the pictures here. The natural frequency is quite excited and has sidebands around it. The 1 in 2 of the gear shoots up. Hunting tooth problem. Ideally, when a tooth tends to hunt for its mating gear is what a hunting tooth problem comes up as, visible here. Now the formula for a hunting tooth is a GMF into NA, which is the number of the assembly phases divided by the teeth on the gear and the teeth on the pinion.